Hello everyone, we're going to do an example problem of a company switching to an ABC system for allocating out their indirect costs. In this problem we have the Boardman dresser company. They make three different types of dressers: single dressers, double dressers, and triple dressers. As of now, this company is using a simple costing system. So they bunch all of those indirect costs into one giant pool, and then they spread it out using one driver, and the driver that they have for their existing system is the quantity of machine setups that each model takes. They have all of the following information, as you can see in that first chart, related to what happened during the 20XX fiscal year. So we have the number of units that were sold for their three respective models, how much they sold each unit of for single, double, and triple dressers respectively, what the material costs were to make any one given unit, what the labor costs per hour were to make any one given unit, and how many hours it took to make any one given unit. We also have how many hours they spent machining each of the three respective models, how many setups each of the three respective models took, and the number of times they had to do inspections to make sure that the models were up to snuff, to their standards, so they could turn around and sell them. They have been thinking, in this case, that they at least want to check the numbers on how the perceived profitability of their three different models changes if they used an ABC system. And under the ABC system, they're proposing, instead of having one giant pool for all costs, they're going to break it down to the four activities they have which contribute the most towards incurring indirect costs, and they are machine setups, machine operations, inspection, and the cost of distribution. Again, the cost of distribution is usually not an inventoriable cost, but because ABC is internal purposes only, it still factors in. I mean, a triple dresser weighs much more than a single dresser. If they're going to have to ship these things, that affects the profitability of that particular model. They're not going to be able to get, they're bigger, they're not going to be able to get as many into a truck. That truck's going to be carrying a much heavier load. It's going to go through more costs of gasoline, etc. to move. So it's very relevant to our decision making. For each of these four activities, they have a cost that they are budgeting for. They believe that machine setups are going to cost $60,000, machine operations are going to cost $150,000, inspection is going to cost $24,000, and distribution costs, because you're not going to distribute a unit unless you're ready to sell it, are based upon sales. It's going to be equal to 2.5% of sales revenue. The drivers for machine setups is the quantity of setups they do. The driver for machine operations is the number of hours it takes to operate machines to make each respective model. The driver for inspections is the number of inspections that they're going to do for each model. And as I stated before, distribution costs are going to be based upon the total sales revenue of each model. So that bottom one's a little weird, because in order to figure out what the what amount is going to be assigned to this activity, we need to figure out firstly what amount of sales revenue are we proposing we're going to generate for each one of these models. So how are we going to figure that out? Well, you can figure out your sales revenue simply by taking how many units of each model you expect to sell and multiplying it by how much you expect to sell each unit for. They are saying they're thinking they're going to sell 2,400 single dressers at an average selling price of $320, and if Boardman hits that mark, they're going to generate $768,000 in sales revenue. For the double dresser, they think they're going to sell 1,600 of those guys at $450 a piece, and 1,600 dressers sold at $450 a pop on average is going to generate $720,000 of sales revenue. And for the triple dressers, much more expensive, not as in demand, they still think they're going to sell 800 of them at a price of $640 a piece. And that's going to add another $512,000 of sales revenue. So what are the total revenues expected to be across all three models? 768 from the single dresser, 720 from the double dresser, and 512 from the triple dresser. All added together means they're going to generate a total of $2 million of sales revenue if they hit their marks for the number of units sold and the selling price they get for each unit. They got to pay to ship these afterwards, and that's variable. Like the more units that they sell, the more they have to pay in distribution costs. So they smartly decided to use a percent of sales revenue as their driver for that activity, and that is 2.5%. So right here, I'm just going to put in 2.5%. Well, what is 2.5% of 2 million? Just take your 2 million, multiply it by 2.5%, and it comes out to 50,000. So they think they're going to spend $50,000 distributing these dressers to their end user to be sold. Well, that's just one of our 4 activities. Thankfully for us, they already have a budgeted amount in mind that someone else has prepared for machine setups, machine operations, and inspection. So we can just go and we can bring all of those numbers down. 60,000 for machine setups, 150,000 for machine operations, and 24,000 for, line underneath, there we go, 24,000 for inspections. They're using a simple system here. One pool, one driver, which means all of these costs are going to get bundled together in one pool. Well, if they're spending 50,000 on distribution and 60,000 on machine setups and 150,000 on machine operations and lastly 24,000 on inspections, that's a total of $284,000 worth of indirect costs that they expect to have in this pool throughout the period, when the period ends. And like all indirect costs, they get pulled up. You need some systematic method to spread those out amongst each unit. Their method is based upon their driver of machine setup quantity. Well, now we got to figure out how many setups in total it's going to take to make all of these different dressers during the period. And we have that information up here. We think that it's going to take 220 setups for the singles, 200 for the doubles, and 180 for the triples. So if we add those 3 numbers together, or if you will, if we find the sum of these 3 numbers, that means that in total, they're going to perform 600 setups during the period. Your predetermined overhead allocation rate is always budgeted costs divided by budgeted quantity of the driver. Well, they're budgeting to spend $284,000 in indirect costs. They're budgeting to have to perform 600 machine setups. So if we just divide that 284,000 by 600, we get, rounded off here, that Boardman dresser is going to allocate out $473.33 to each respective model every time they have to do a setup for that model. That's going to be their methodology for getting those costs out into their different models of dresser. Well, how do we determine therefore what our cost is going to be for each dresser when we record COGS, etc.? Well, we can start by finding how much they have to spend for their 3 cost components, which is direct materials, direct labor, and the amount of overhead or indirect costs that are being allocated. For direct materials on the single dresser, we know how much each dresser is expected to cost in materials, $96. We know that we're planning to make and sell 2,400 dressers, so to figure out what our total expected direct material costs are for that model, we just simply take the number of units sold and multiply it by the direct material cost per unit. That comes out to $230,400. I can repeat that same process for the double and the triple dresser. For the double dresser, we're expecting to sell 1,600 of those. Each one of them is expected to cost $168 in materials to produce, which means the total material cost of making those 1,600 double dressers is going to be $268,800. And then for the triple dresser, one more time, we're going to take the expected quantity sold of 800, multiply it by the expected material cost to make one triple dresser of $216, and 800 times 216 comes out to be $172,800. So we have our expected material costs for each different model. Let's do a series of calculations here to figure out what our expected labor costs are for each model. What do we have to work with? We have how many units of each we're going to make. We have our labor cost per hour for each one of those units, but not every unit takes an hour to make. Like, you can't just multiply number of units sold by labor cost per hour. That would be assuming that it only takes 1 hour a piece to make a single, double, or triple. And I think it's logical to think that a single, double, or a single dresser is faster to produce than a double, and a double is faster than a triple. Well, thankfully we have that information because we know that it takes 2 hours to make a single, 3.25 hours or 3 hours and 15 minutes, if you will, to make a double, and 4 hours to make a triple. Well, I think given this information, if we take the number of units that are going to be sold of each model, multiply it by how much we're paying in labor costs, which is an average of $20 an hour, and multiply that by the number of hours it takes to produce each model, we're going to come up with our total labor cost to produce all 2,400, in this case, of those single dressers. So I'm going to come down here, And I'm going to hit equals, and I'm going to go back up, and I'm going to multiply 2400 times our labor cost per hour of 20 times the time to produce each unit, which is 2 hours, and I come up with a total of $96,000. So we're expecting to incur $96,000 of labor costs to make single dressers. For the double dresser, let's do the same methodology. It is 1,600 double dressers to be made and sold. We're going to pay an average rate of $20 per hour to our direct laborers. And for this particular model, it takes 3.25 hours to manufacture a double dresser. Well, that means that at those expected inputs, Boardman Dresser Company is going to have to pay $104,000 in labor costs to make double dressers during the period. And lastly, for the triple dresser, we're going to take the number of units expected to be sold, which is 800, multiply it by that $20 labor cost per hour, and multiply that by the 4 hours it takes to make each triple dresser, and we come up with a total of $64,000. So we're expecting it's going to take $64,000 worth of labor costs to complete the production of those triple dressers. For our third cost component, we need to allocate out all of those pooled costs in our indirect pool or our manufacturing overhead pool into the different dresser models. And thankfully, we've already figured out our predetermined overhead allocation rate. We are going to allocate overhead to these models at a rate of $473.33 for each machine setup a model takes. Well, to get these costs in here, let's just take that predetermined rate and multiply it by the quantity of the driver, the number of setups. And for the single dresser, we're expected to have to do 220 machine setups. And 220 machine setups at a rate of $473.33 per setup means that $104,133 of overhead costs are going to be allocated to that model. For the double dresser, at a rate of $473.33 per setup and a total of 200 expected setups, we'll have $94,667 allocated to that model. And for the triple dresser, with our same rate of $473.33, at a total number of setups of 180, we will allocate $85,200 in indirect costs to that particular model. And now that we have our three cost components, we can find the total expected cost of each model during the period. For the single dresser, we are expected to have to incur a total amount of materials costs of $230,400, labor costs of $96,000, and a total indirect costs of $104,133. If we find the sum of those three numbers, that means the total cost of producing single dressers is going to be $430,533. And then through the magic of the fill handle, I'm going to go down in the corner here until our cross turns to a little smaller black cross. I'm going to drag across. We're going to find out that the total expected cost of double dressers for the period is $467,467. And for the triple dresser, we're proposing that we're going to have to pay $322,000 on the dot in costs. Well, how much is that per unit? Well, if we just take our total costs to make all units and divide it by the number of units of that model we're going to make, we get the cost per unit. So what is the number of units that we were planning to produce and sell for the single, double, and triple dresser? We're planning on producing and selling 2,400 singles, 1,600 doubles, and 800 triples. I'm just going to click on that 2,400 and hit enter. And then I'm going to fill handle to bring in the rest of those numbers. So we got 2,400 singles, 1,600 doubles, and 800 triples. Now I can just go and I can take our total costs, divide by our number of units produced of that model, and I come up with our expected cost per unit. We're saying here that if we use the simple system, using only quantity of machine setups as our driver, our perceived expected cost for a single dresser for the period is going to be $179.39. For the double dresser, it's going to be $292.17, and for the triple dresser, it's going to be $402.50. So that is our simple system. Under that system, we came up with those costs. And what we want to know by switching to an ABC system where we have different pools with different drivers, is it going to change the perceived cost that we're paying to make each of these respective models? So let's start with machine setups. What is our expected indirect costs for machine setups during the period. We started with that right in the beginning. It was $60,000. Our driver for machine setups is, it says per setup here, the number, or here, of setups. Well, how many setups are we going to have to do during the period in total? Well, we're going to have to do, if I hit equals here, and scroll back up to my information, 220 for the single, 200 for the double, and 180 for the triple. That is in total 600 setups. Well, if we have to spread $60,000 worth of indirect costs for that activity out amongst 600 setups, how much cost are we going to spread out per setup? 60,000 divided by 600 means that our allocation rate is going to be $100 per setup. So under this system, every time we do a setup, we're going to put $100 of indirect costs into that model. What about machine operations? What was our budgeted expected cost for that activity? We have that up here. It was $150,000. Our driver for machine operations per machine hour, and machine hours is the number of machine hours we're going to spend in total to make all of our different products. Well, if we go back up here, our number of machine hours for the single is 4,000. Our number of machine hours for the double is 4,400. And the number of machine hours we're going to have to utilize to produce all of those triple dressers is 6,600. And if we total all three of those together, Boardman Dresser Company is going to spend 15,000 hours machining dressers during this period. Rate is always budgeted cost divided by budgeted quantity of the driver, which means with this information, we've determined that our allocation rate for all of the costs that we're going to incur because of machine operations should be $10 per every machine hour a model takes. For inspections, we have a total expected cost of $24,000 to pay our inspectors to look over all of the stuff. The driver is per inspection, number of inspections. How many inspections are we going to have to do in total to inspect all of our different dresser styles? Well, we're going to have to do 30 inspections to look over the single dressers, 25 to look over the doubles, and 25 to look over the triples. That is a total of 80 inspections that we're going to do across all models. Well, if we're going to spend $24,000 to do all of the inspections, and we're going to do 80 of them, that means that each inspection that we do is causing us to incur $300 in indirect costs. So that's the rate that we're going to allocate out costs from that particular pool to the different units. And then lastly, we have our allocation rate for distribution costs. Well, we don't have to mess around with this one with a bunch of calculations. We stated right at the beginning, since that's going to be variable to how many units we're selling and ultimately shipping, it should be based upon the amount of sales revenue that we do. So our rate here is per sales dollar. If it's 2.5% of sales revenue, how much of each sales dollar, or how much is each sales dollar we do going to cause us to incur in distribution costs? 2.5 cents, 0.025. And now that we have all of this information, we can use this ABC system to figure out what is our expected cost per unit. See if it changes from the numbers we came up with up here for the simple system. Well, our first cost component is direct materials. Changing from a simple system to an ABC system is only changing the way that you allocate out indirect costs. And direct materials is not an indirect cost. What I'm getting at here is just because we change allocation methods for indirect costs, it in no way changes the direct costs that we're recognizing for each model. We have a system in place to track those. So the materials cost for a single is still going to be $230,400, just like it was above. The materials cost for producing double dressers is going to be $268,800, like it was above. And the material cost for triple dressers is still going to be $178,800, like it was above. Our next cost component is direct manufacturing labor. Direct manufacturing labor, again, is not going to change because we changed our allocation system. We changed the way that we perceived overhead, because it also is a direct cost, which means even if we switch systems, we're tracing directly how many hours our laborers are working on each of these respective models, and therefore these numbers will not change. It's still going to be $96,000 for a single. it's still going to be $104,000 for a double, and it's still going to be $64,000 for the triples. Up here we have on the top. So just reiterate one more time, direct costs do not change ever when you change your system for allocating out indirect costs, because they are in fact direct costs. Now for all of our indirect costs, we got a little more math to do. The first thing is how much cost is going to go into each of our respective models because of machine setups. Well, the good news is we found our allocation rate for that activity. So if we just take our allocation rate for that activity and we multiply it by the quantity of the driver, in this case setups, that each respective model is going to require, we get how much money is going to be taken out of that pool and put into that respective model for this particular activity. So for machine setups, we're allocating at a rate of $100 per hour. How many machine setups are we going to have the single dresser? We saw this up above. The single dresser is going to require 220 setups. So if we put $100 into that particular model's perceived cost for each setup, and we're doing 220 setups, that means that in total, $22,000 of indirect costs should be allocated to the single dresser for the number of machine setups that it makes us do. And we're going to use that same methodology to spread out costs from that pool, that $60,000 of cost, to our other models at a rate of $100 per setup. And knowing that we're going to expect to do 200 setups for the doubles, that means that the double dressers will end up having $20,000 of indirect costs allocated to that model for the setup activity. And then lastly, at a rate of $100 per setup, the triple dresser, which is going to require expectedly 180 setups, should have $18,000 of indirect costs allocated to it for that activity. And just real fast to be thorough here, I'm going to add those three numbers together, and they're going to add up to 60,000. And they should. That was our expected activity cost for that particular activity. So that's how we're proposing the $60,000 is expected to be spread out amongst our different models. $22,000 to the singles, $20,000 to the doubles, and $18,000 to the triples. What about machine operations? Same concept. Take your predetermined overhead allocation rate and multiply it by the quantity of the driver that you expect that model to cause your company to incur. So machine operations has a predetermined rate of $10 per machine hour. The single dresser is expected to take 4,000 machine hours to manufacture during the period. So making single dressers is going to cause Boardman to incur $40,000 of indirect costs for that activity. For the double dresser, the rate is still $10. We multiply that by the number of machine hours that we are expecting double dressers to take us, which is 4,400. We're going to come up with $44,000 of indirect costs that should be allocated to the double dresser product line because of the costs that we incur for machine operations, electricity, depreciation, etc. For the triple dresser, at a rate of $10 per machine hour and an expected quantity of 6,600 machine hours necessary to produce those triple dressers, we're going to have $66,000 of indirect costs, which should be allocated to that model. And if you add together 40,000, 44,000, and 66,000, you're going to come up with 150,000, which again was our total expected activity cost for that particular activity. Lastly, we've got inspection. Inspection has a rate of $300 per inspection. So if we just take that rate, multiply it by the number of inspections each model is going to cause us to have to do, we get how much indirect cost we should be allocating to that model. For the 30 inspections that the single dressers are expected to take at a rate of $300 per inspection, we should have $9,000 of indirect costs getting allocated to the single dresser for that activity at a rate of $300 per inspection, and 25 inspections we're expecting for the double dresser. That is a total of $7,500 that's going to get allocated to that model, and 300 times 25 for the triple means that one is also going to get $7,500 worth of indirect costs allocated to it for the activity of inspecting our finished dressers to make sure that they're ready to be sold. And then lastly, we have distribution costs. And our rate is 2.5 cents per sales dollar. Which means if we go through and we find our expected sales for each individual model that we have and we multiply it by 0.025, we get how much distribution costs we can expect to have to incur from each of those models. And thankfully, we started up here by figuring out what our sales revenue was for each particular model. So if I go through and I take our sales revenue of $768,000 for that model, multiply it by the 0.025 rate that we have here, come up with $19,200. If we allocate 2.5 cents of distribution costs to the single dresser for each dollar of sales that model generates, and that model is going to generate $768,000 worth of sales, that means $19,200 worth of cost is going to get allocated to that model. Same thing over here, 2.5 cents per sales dollar to the double dresser, which we are expecting is going to generate $720,000 of sales revenue for us. Means we're going to incur $18,000 of distribution costs shipping those finished double dressers to their end user, and at a rate of 2.5 cents per sales dollar. For the triple dresser, and it's $512,000 of expected sales revenue, means we can expect the triple dresser to cause us to incur $12,800 of distribution costs. And let me just fill handle on down here to make sure this all lines up. That is a total of $24,000 of inspection costs. That's good. And a total of $50,000 worth of distribution costs, which is, in fact, 2.5% of our $2 million of expected total revenue. So we're good. We got everything spread out, which means we can now figure out the perceived total cost of each model under the ABC system. I'm just going to find the sum of all the numbers that are up above it. The single dresser for its materials, labor, and all the different costs that we're going to spread out of our now 4 respective indirect cost pools. We are saying this model is going to cost us $416,600 in total to produce during the period. For the double dresser, it's going to have a total cost of $462,300 during the period. And for the triple dresser, it's going to have a total cost of $341,100 during the period. Well, now we need to find our cost per unit. The number of units that we expect to sell of each model is not going to change because we have a different way of allocating out indirect costs. It's going to be exactly the same as it was under our simple system. And we have those numbers above. It was 2,400 single dressers expected to be sold, 1,600 double dressers expected to be sold, and 800 triple dressers expected to be sold. So I can just go and I can fill in those numbers. And then I can divide our total costs per model by the number of units we expect to sell of each model, and I get our new cost per unit. So under this different system, this ABC system, the total cost of producing a single dresser, the way we're perceiving it, is going to be $173.58, which is down from the $179.29 we had up above. The double dresser has a perceived cost of $288.94 versus the $292.17 that we had above, so that is also cheaper. But the triple dresser has its cost per unit up to $426.38, well above the $402.50 that we were expecting above. So under this system, the triple dresser looks much more expensive to make than it did before, and that's information that we can use to determine pricing points. That's information that we can use to determine, do we still even want to produce triple dressers? They're our lowest seller in terms of quantity. Again, this system, the ABC system, is there for managerial decisions. So armed with that information, it's looking a lot better for the single and double right now versus when it did with our simple system than it is for the triple.